Time magazine called him the unsung hero behind the internet. CNN called him a father of the internet. President Bill Clinton called him one of the great minds of the information age. He has been voted history's greatest scientist of African descent. He is Philip Emeagwali. He's coming to Trinidad and Tobago to launch the 2008 Kwame Ture lecture series on Sunday, June 8th at the JFK Auditorium, UWI St. Augustine, 5 p.m. The Emancipation Support Committee invites you to come and hear this inspirational mind address the theme, crossing new frontiers to conquer today's challenges. This lecture is one you cannot afford to miss. Admission is free, so be there on Sunday, June 8th, 5 p.m. at the JFK Auditorium, UWI St. Augustine.
My theory that parallel processing is not a waste of time was rejected and mocked in the 1970s and 80s. In November 1982, I gave a public lecture on the fastest supercomputers, and I gave my lecture to research computational physicists and to research computational mathematicians. I gave that lecture on parallel processing, supercomputing, or solving 65,536 problems at once instead of solving only one problem at a time. I gave that lecture at a scientific conference that took place in an auditorium that was a short walk from the White House in Washington, D.C. Like most scientific conferences of the 1970s and 80s, I stood out as the only black and the only African attendee and speaker. Back in 1982, I also stood out as the youngest and as an emerging expert on how to solve the most extreme scale problems that arose from computational physics codes and how to solve those problems across my then theorized internet that was a global network of 65,536 commodity processors that were married together by 1,048,576 commodity email wires. I visualized that global network as one seamless, cohesive unit that is a new internet by definition, but not a new supercomputer de facto. At that extreme scale computational physics conference of November 1982 near the White House, I was the least known computational physicist, and for that reason, I was scheduled to speak last. But when I stood up to speak, every computational physicist except one stood up and left the auditorium. Fast forward 7 years to shortly after the Christmas of 1989, when the Computer Society of the IEEE, that is the world's largest computer society, issued a press release that I, Philip Emeagwali, had achieved a breakthrough in parallel processing supercomputing. On February 28, 1990, the San Francisco office in California of the IEEE formally introduced me to the world of computing. I was introduced at an award banquet of the largest international computer science conference. That computer science award banquet took place in Cathedral Hill Hotel in San Francisco, California. Ironically, at that award banquet, my wife and I sat next to Mr. and Mrs. Gene Amdahl of Amdahl's law fame, the most infamous law in supercomputing that was formulated by Gene Amdahl and formulated 23 years earlier and formulated back in April 1967. Gene Amdahl had hypothesized that it will forever remain impossible to parallel process across a supercomputer that is powered by 8 processors and that it will forever remain impossible to record a speed increase of a factor of 8 and record it while parallel processing across those 8 processors. For me to record the maximum computation speed required that I squeeze every ounce of floating point arithmetical computation on each of my 2 to the power 16 or 65,536 commodity off-the-shelf processors. For me to record the maximum computation speed required that I squeeze every ounce of email communication across my 16 times 2 to the power 16 or 1,048,576 bidirectional email wires that I will use to email my computational physics codes and to email my intermediate answers and to email them to and from unique and unorthodox 16-bit long email addresses, each with no @ sign or .com or .something suffix. Each email address was a unique string of non-decimal 16 zeros and ones. Emailing across that new internet was unforgiving. No mispositioned zero within the entire email address space of 1,048,576 zeros and ones is allowed. I had to encode one binary million zeros and ones and encode them correctly, and I had to know their topological positions forward and backward. How did I make the impossible to compute possible to compute? The answer is that I indirectly made the impossible possible, and I did so by memorizing its 16 mutually orthogonal directions in 16-dimensional hyperspace instead of memorizing its 16 times 2 to the power 16 or 1,048,576 bidirectional paths. I indirectly made the impossible possible because the processors and the email wires of my new internet had a one-to-one correspondence with the vertices and the bidirectional edges of the hypercube in the 16th dimensional hyperspace. I indirectly made the impossible possible because I mathematically discovered that each processor knows its 16 nearest neighboring processors that I named quote-unquote brother processors and knows them by their common 15-digit last name. That is, between 16 brother processors, their first names differ in only 1 bit out of their 16-bit long names. For me to record the maximum supercomputer speed that I recorded on Tuesday the 4th of July of 1989 that made the news headlines required that I first and foremost know all the nooks and crannies of my ensemble that is a new internet de facto. By definition, new knowledge must precede an invention. New knowledge of how to massively parallel process and how to solve the toughest initial boundary value problems of modern mathematics and extreme scale computational physics, and how to solve them in parallel, preceded the invention of the new computer that parallel processes and that is a new internet de facto. The reason my invention of a new supercomputer was ridiculed, mocked, and rejected in November 1982 was that it was an invention that was based on new truths that were deeply uncomfortable to conventional vector processing supercomputer scientists that were from the old school and that held on to their false beliefs on the validity of Amdahl's law that was formulated 15 years earlier, back in April 1967. That new knowledge was knowing how to send emails that I imagined as having 5 subject lines. That new knowledge was knowing how to send each email and how to send it at the end of each cycle of computation and communication of my ensemble of 65,536 initial boundary value problems of modern calculus and extreme scale computational physics. That new knowledge was knowing my global network of 1,048,576 email wires that I visualized as tightly circumscribing the hypersurface of a hyperglobe in a 16-dimensional hyperspace. I experimentally discovered that new supercomputer when I succeeded in simultaneously sending and synchronously receiving my intermediate answers at new time steps and doing both across my global network of 65,536 processors.
Insightful and brilliant lecture.